See, PN junction diode, the first part of the microelectronics. Okay, in microelectronics, we have PN junction diode, then we have Zener diode, we have tunnel diode, then we have transistors. But transistors are removed from the syllabus. Okay, so it forms actually the basic diode. So diode means what? Two pins. Okay, it is having two terminals. All two pins is said to be a diode. Now, when a P-type substrate, you know what is P-type substrate and N-type substrate. So when a P-type substrate and an N-type substrate, when a P-type substrate and an N-type substrate, when they come together and uh, they form a junction. Okay, they form a diode. Okay, these are the two terminals. Okay, so we have P-type substrate and it's brought very close to N-type substrate. Then that is known as a PN junction diode. Okay, that is known as a PN junction diode. And this one is what the layer formed here is known as depletion layer. Okay, depletion region or depletion layer. Okay, is known as depletion region or depletion layer. So depletion region or depletion layer, and also this is also known as potential barrier. Okay, this is also known as potential barrier. Now we will discuss about this. See here, in what is a carrier charge carriers in P-type semiconductor? No. Yeah, what are the charge carriers in P-type semiconductor and N-type semiconductor? Can you please tell me? What are the charge carriers in P-type semiconductor and N-type semiconductor?
So 3 and 4.
Yeah, in P-type semiconductor.
3 and 4th valence shell, right?
Hmm? Okay, so in P-type the P-type semiconductor, if you take the charge carriers are holes. Okay, majority charge carriers are holes. In N-type semiconductor, majority charge carriers are electrons. Okay, and minority charge carriers here are holes. So this depletion region is formed due to the minority charge carriers. Depletion region is formed due to the minority charge carriers. Like suppose if you take P-type semiconductor, there are more holes. Okay, more holes, and here there are more electrons. Here there are more electrons. Okay, so here all the holes will come here. Okay, and all the electrons will come here, and they form a junction. That junction is known as PN junction, and that layer is known as depletion region or depletion layer, and the barrier is known as potential barrier. Okay, that barrier is known as potential barrier. Okay, now what is the thickness of the region? We'll discuss about that. So the thickness, okay. So the thickness of this is 0.50, or we also known as this is also known as space charge region. Okay, space charge region. There are two names for this. Depletion layer. We say depletion layer. We say space charge region, or we say potential band. Okay. So now what is the thickness of this? The thickness of this is what? The thickness of the depletion region. The thickness is 0.5 micrometer. Okay. Thickness of this is what? 0.5 micrometer. Yeah. Now, so what is for germanium? How much it is? The potential barrier. The potential barrier value. If it is for germanium, it is around 0.3 volts. Okay, it is 0.3 volts, and for silicon, it is 0.7 volt. Okay, for this it is 0.3 volt for germanium and 0.7 volt for silicon. Okay, now why we say it as potential barrier now? See, if you take a cell or something, so you or a voltmeter, you will easily find a small potential difference developed across the barrier. small potential difference is developed across the barrier. And once again, this depletion region is formed due to the minority charge carriers, not the majority. Okay, due to minority charge carriers. Now here, that was about the PN junction diode. Is it clear?
So can you explain once again?
See, when a P-type substrate is brought very close to N-type substrate, a PN junction diode is formed. And now, when there is a junction formed due to the minority charge carriers. In P-type, minority are electrons. In N-type, minority are holes. They come together and form a layer, depletion region or space charge region. And the thickness of that region is 0.5 micrometer. And a small potential is developed because of the minority charge carrier that is known as potential barrier. And that in case of germanium, it is 0.3 volts. And in case of silicon, it is 0.7 volts. Okay, these values are very important. Okay, they are asking these values in the examination. Is that clear?
Okay, sir.
So then quickly we'll go to the forward bias and reverse bias. Copy this one, and then okay, starting with forward bias, then I'll go to reverse bias. Okay, so starting with forward bias, what is forward bias? When a P-type substrate is connected to positive and N-type substrate is connected to negative. So what is biasing first of all? Okay, so first we'll discuss about biasing. Then we will go with forward bias, and then we will go with reverse bias. Okay, what is biasing means? Application of voltage. Biasing means application of voltage. Biasing is application of voltage. So to make junction PN junction to conduct, we have to make electrons move from N region to P region, and P type to the P type region, and holes moving in the reverse direction. Okay, so here I'll write to make a PN junction, to make a PN junction to conduct. To make a PN junction conduct, we have to make electrons. We have to make electrons. We have to make electrons move from the N-type, move from the N-type region, N-type region to the P-type region. N-type region to P-type region, and holes moving in reverse direction. Holes moving in reverse direction. Holes moving in reverse direction. Okay. Once again, see here, biasing means application of voltage. A proper application of voltage means that there only current will flow. So to make a PN junction diode to conduct, we have to make electrons move from N-type. So we have to make electrons move from N-type region to P-type region, and holes moving in the opposite direction. So this is said to be biasing. Now we will go with forward bias and reverse bias. Okay, is that clear? We'll go with forward bias and reverse bias. So yeah, biasing, see once again, in the junction I have explained, okay, in the PN junction, what will happen? Once again, quickly see here. If you draw a PN junction diode, how it is? So there is a, this is the minority charge. This is P-type, this is N-type. Here all are holes, okay. Here all are holes, and here all are electrons, okay. These are electrons. And minority, here there are holes, and here there are electrons. Okay, here, and this is positive and negative. Okay, so what will happen? So here what will happen? P is connected to, so P is majority charge carriers are holes, and minority are electrons in P type, and in N type majority are electrons and minority are holes. So they form a junction. Okay, this forms a junction here. So the junction is formed due to the minority charge carriers. Clear? The junction is formed due to the minority charge carriers. Understood? So that layer, that region is known as space charge region or depletion region, and the thickness is 0.5 micrometer. And also the small potential is developed across this junction, that is known as PN junction, or that is also known as potential barrier. Okay. Now coming to the biasing, what is biasing? Biasing means application of voltage. To make a PN junction to conduct, we have to make electrons move from the N-type region to P-type region, and holes moving in reverse direction. Next is forward bias. What is forward bias? If P is connected to positive and N is connected to negative terminal of the battery, then it is known as forward bias. Then I will draw the figure here. I will draw the diagram. Then about forward bias. Okay. So what happens here in forward bias? This is the symbol of diode. Okay. This is a symbol of diode. This is P and this is N. Now this is voltage. And here we have, what do we have? This is a switch. And this is a variable battery, positive, negative. And here we have milliammeter. Clear? This is a milliammeter. So this is a PN junction diode. So when P is connected to P is connected to positive and N is connected to negative, then it forms a PN junction diode. Okay. So here voltmeter is connected parallel, ammeter is connected in series. There is milliammeter. So milliammeter means how much? It is the magnitude is 10 to the power of -3 amperes. Milliammeter means 10 to the power of -3. Now the same thing I am drawing it again here with the junction. Okay, suppose here we have this is positive and this is negative. So all the holes are moving in this direction. Okay. All the holes are moving in this direction. This is for P, and this is N. Electrons are moving in the opposite direction. So what happens when you close the switch positive, when P is connected to positive, means what happens? P is connected to positive, N is connected to negative. So what happens? Electron starts flowing. So here what happens? Electron starts moving here. Okay, and when electrons start moving here, holes start moving in the opposite direction. When we say flow of holes, actually what happens when electrons are moving in the forward direction, it is leaving a vacancy behind. In simple words, that is itself a hole. Means when electrons are moving forward, holes start moving backward. Is that clear? When electrons are moving forward, holes start moving in the backward direction. So here what happens now? So here this is a N type. Okay, is that clear now? So this is a electron. Electrons start moving from N to P, and holes start moving from P to N. Is that clear? So this is about the forward bias. So how will be the variation? So in forward bias 0, 0.1 to 1 means what? You start with 0. The last voltage will be 1 voltage with a variation of 0.1. Means increment value is 0.1. You cannot go beyond 1 voltage in forward bias. Means how, like instead of writing 0, 0, 0.1, 0.2, dash, 1.0, I'm just writing here 0, 0.1, that is increment value. 0.1 is the increment value. Do not go more than 1. If you go more than 1, the barrier will break. What happens? The barrier is becoming very, very thin. As you increase the voltage, what happens? The barrier becomes thin, and electrons start flowing from N to P, and holes start moving in the opposite direction. Is that clear? Is it clear?
Yes, sir.
Okay. Please copy this one quickly. Then we'll go to the that is reverse bias. Okay. Once again, I will explain here. See, here this is a diode. This is a diode. Voltmeter is connected in parallel. Ammeter is connected in series. This is a switch, and this is a variable power supply. If P is connected to negative and N is connected to positive, then that is known as reverse bias. Now, what happens? P is connected to negative, N is connected to positive. Both here, electrons and holes, they both move in the opposite direction. Okay, so electron-hole recombination takes place at the junction region. Okay, what happens? Actually, both are moving, electron and hole, they both are moving in opposite direction. So, because of that, what happens? The barrier will become very, very thick, and a small current flows only due to the electron-hole recombination. So, and the increment, how is the increment value? 0, 1, 0, 1 and 10 means the increment is 1 means 0, 1, 2, 1, 2, 3, 4 up to 10. Means you have to increase the voltage like with a difference of 1, maximum is 10. Should not increase more than 10. If you increase more than 10, then the diode will be spoiled. Okay? Clear?
Yes, sir.
In forward bias, when you apply the voltage, immediately the current will not start flowing. So current starts flowing from 0.7 voltage something. This particular voltage is known as knee voltage, okay, or threshold voltage. So the forward voltage required to get the junction in conduction mode. The forward voltage, required to get the junction in, required to get the junction required to get the junction in conduction mode. In conduction mode, okay, is knee voltage. Okay, is knee voltage. Okay, so it is 0.7 in silicon. It is 0.7 voltage in silicon and 0.3 voltage in germanium. Okay. Okay, 0.7 volts in silicon and 0.3 voltage in germanium. Okay. Here. And the maximum, what happens, the current may attain the 30 to 80 milliamperes. Maximum current can be the current attained. The current attained is 30 to 80 milliamperes. Okay. It is 30 to 80 milliamperes. So this is the total one. This happens in the forward bias. Okay. Clear?
Yes, sir.